รู้จักอะไรเหรออืม and it's free to download and install.
เริ่มใหม่
And that means you'll be using the
ดู
same
สภาพว่า
development
ไก่จ
environment
ริง
that's used by professional Android developers every day to design and program Android apps, as well as to get apps ready to be published on the Google Play Store. Now, I've done plenty of
ๆ
talking.
ไม่ได้ตั้งใจ
We
เล่นเลย
believe in learning by doing. In the next videos, I'll show you how to get your machine configured to get set up with Android Studio. I'll see you there.
น่าเล่นกับคนใช่ไหม
On the full course, you're going to get access to a huge bundle that we've compiled just for you. Now let me show you what this bundle includes. You're going to get access to a whole bunch of icons, which you'll be able to use within your app. You're also getting a load of gradients, which can be used as app backgrounds, as well as HD photos and faces for avatars. There's also a load of Photoshop files for buttons and controls, as well as a whole bunch of app mockups in Sketch and in Photoshop. And finally, we've included app icon builders for iOS and Android, so you'll be able to easily create your app icons and export them in all the right sizes. Now, collectively, this huge bundle of image assets is worth over $5,000, but we're going to give it to you for free as a part of this course to make life easy for you when you're creating your own apps. Now, on top of this massive bundle of image assets, we're also giving you access to our highly rated 12 Rules to Learn to Code book that consolidates some of our best tips for how you should go about approaching learning to code. So once you're ready, if you head over to your course contents, you'll be able to download all of these files.
One thing I'll say is that you'll get a massive performance boost if your machine doesn't have a spinning magnetic disk for a hard drive. If you've got an SSD, then Android Studio will run much, much faster. What is Android Studio? Android Studio is the official development environment that is supported by Google to make apps for Android. We'll be using Android Studio both to write the logic of our apps as well as to design the look and feel of them. Now, when it comes to running the apps that you've built, I recommend running them on a physical Android device. But if you don't have one, you can always try running them in an emulator as well. An emulator is a virtual device that's going to be running on your machine, but it takes up quite a few resources. It doesn't boot up that quickly. So if you've got a physical phone or a tablet that's running Android, even a Kindle Fire, I recommend using that instead. The Java development kit includes things like the Java runtime environment and the Java compiler. So how do we check if we've already got it? Click on search and open your terminal. From there, just type Java space dash version. Now, if you've already got Java installed, and your version number will pop up here, and we're looking for something 1.8 or higher. So I've got 1.8.0_77, and that's fine. If you don't have the Java development environment installed, you will see a different message. You will see something like this: no Java runtime present. In this video, we're going to talk about how to get set up for Android development on Windows. I'm going to show you all the tools that you need to download to get set up for making Android apps on a Windows machine. Now, for part of this demo, I'll be sharing a screen on a machine that's running Windows 8. If you're running Windows 10, it might be slightly different, but it shouldn't be too far off. The first thing we're going to do is check if we're running a 64-bit or a 32-bit machine. So go to your control panel. You can find it under Settings, Control Panel, and then click on System. And there you'll be able to find your system type. Mine says 64-bit operating system. So make a note if you've got a 64-bit or a 32-bit machine. Most modern computers will probably be 64-bit. Now it's time to check if you've got the Java Development Kit. The Java Development Kit is what you'll need to make Android apps, or any Java program for that matter. The JDK in system type. Mine Java Development K, and then click About. Java Development Options, Oracle bragging how many devices run Java. Again, we'll be presented with a wizard where we have to agree to the terms and conditions. I wonder who actually reads these. I'm pretty sure that by now I've promised somebody my firstborn child. Now, Android Studio is actually a pretty large file, and it seems to be getting larger with every update. After the download has finished, follow the setup. Pod. Fire up Android Studio. It's time to start. Pod. Fire up Android Studio. It's time to start that program. Sorted. Now it's time to configure our physical device so that we can install our app. And in the setting where it's buried at Developer Club, we're making sure the phone is being and select sorted. Now it's time to configure and select check for updates. Chances are there are some updates available that you should install. Okay, so now we've got the JDK sorted and Android Studio sorted. Now it's time to configure our physical device so that we can install our apps on it. Take your physical Android phone and go to the settings. And then in the settings, scroll all the way down where it says About or About Phone. And there you'll have to look for something called a build number. So on this HTC that I've got, it's under Software Information and then More. And there it's buried as a line item. Now start tapping on that build number. After you've tapped on it a couple of times, you're going to see these messages start appearing. You are X steps away from being a developer. So after you've tapped it 7 times, you become part of the secret developer club, and a secret menu appears. So if you go back to your settings now, you'll see a menu that was previously hidden, namely the developer options menu. So go into the developer options for your phone, and search for an item that reads USB debugging. Make sure you enable USB debugging, make sure your next running. Connect our device to our In this video, we're going to configure Android Studio to make our workflow a little bit easier. But first, we're going to create a dedicated folder on our computer where we're going to save all our work. Since I mostly work on a Mac, I'm going to create mine under Documents, and there I'm going to create a new folder and call it Projects. But if you're on Windows, make sure you create your Projects folder right on your local disk. So navigate to your C drive and create your Projects folder there. And the reason you want to do this on a Windows machine is because if you create your projects folder somewhere else, like in your documents or wherever else you like to store your work, you're going to run into an issue later on, because Windows actually has a limit on how long the file path can be. Long story short, just create the folder directly on your C drive. Next, we're going to fire up Android Studio and change some of the preferences. So fire up Android Studio, wait for it to load, and then go to Configure Preferences. On Windows, it's very similar. That menu is just called Settings. Now, if you've already opened a project and don't see the splash screen, you can always access the settings under File and then Settings. First, I want to show you how you can actually configure the look of Android Studio. Now, you're going to be spending a lot of time in the software, so configuring it so that it looks right to you and so that your eyes don't get tired looking at the screen for a long time is actually quite important. Add unambiguous imports on the fly. Now, Android Studio is a very, very powerful and complex piece of software, but one of the things we're going to be using it for is auto-generating some boilerplate code for us. So it's a good idea that we specify what sort of naming conventions we want Android Studio to use when it generates that code. Now, naming conventions are very much a stylistic thing, and you'll see that everybody has their own preferences and their own rules that they follow, and that naming conventions differ quite drastically from company to company. But here are the naming conventions that we're going to use. Under the editor menu, expand Code Style, and then click on Java. Then go to the Code Generation tab, and under Name Prefix, put an M for field, and put a lowercase s for static field. And that's it. Just click Apply, and we're done. Lastly, we're going to check the installed SDK platforms. SDK stands for Software Development Kit, and it's a software package that allows you to build Android apps for a particular version of Android. You can even make this to pick the latest one, you'll be able to don't just run apps on this older device. So a good idea here is to pick the latest one, like Android Oreo, and then also pick the Android version that is actually running on your physical device if you own an Android phone or tablet. So I personally own a older Android phone that's still running Lollipop and never got an update from HTC. So I also have to take Magda because sometimes I want to test and try to run my apps on this older device. So if you're not sure what sort of Android version your own device is actually running, you'll be able to find this information in the system preferences of your device. And it's going to be located somewhere similar where that build number was that you clicked on to enable your developer settings. So whatever you do, don't just blindly put a tick box next to all of these. You don't really need to install all the SDK platforms. That's just going to take up a bunch of space on your computer. So speaking of space, you don't actually have to install all the components that are in the package. So you can see here that I've got Android Nougat installed, but I've got Android Oreo partially installed. So down here, you'll see a little box called Show Package Details. So if I tick this, I can actually see the subcomponents, if you will, of what makes up this package. So one of the things that you'll notice is that you don't actually have to tick all these boxes, right? You don't have to install the Android Wear system image if you're not planning to make an app that's going to be targeting Android Wear running an API level of 26. And the same goes for the Android TV and what have you, right? So you can install the things that you need, but are pretty good. You hit up after the wizard is all done, you can just click finish and then hit OK. So in this video, I'm going to show you how to set up an Android emulator. The Android emulator is a virtual device that runs on your computer. In other words, it's a piece of software that pretends to have all the hardware components of an actual phone. So why would you want to bother with this? Why would you want to set up an emulator in the first place? Well, one of the big reasons is that you don't have to have a physical Android phone to test your apps out. So for example, if you have a problem connecting the phone that you do own, you can always test your apps on an emulator. You know, say you're out and about, you're traveling, or you're in a coffee shop and you forgot your cable, well, fear not, you can always test your apps. Second, you can test your apps on devices you don't actually own, right? So if you wanted to run the apps on the newest Samsung phone, you can. If you wanted to run your app on an Android Wear device, again, you can. Or say you wanted to test your app on an older version of Android or a less powerful device, then you can also do that. So an emulator is actually really, really handy when it comes to test your computer. If you're running a Mac, you've got it. Android Studio is a big program and it requires a lot of resources to run. And if it's laggy or slow, it can make the whole development experience quite frustrating. So we're going to go over 4 quick tips to speed up your PC. Tip 1 is close all other programs. If you've got Chrome or other things running, they take up quite a lot of resources. Press Ctrl-Alt-Delete and bring up your task manager. If you see this view, press More Detail. Alright, so let's get started with our very first app. This is going to be a twist on the Hello World app, and it's got an interesting story behind it. Back in 2008, there was a chap called Armin Heinrich who created an app that did absolutely nothing. All it did was show a picture of a diamond on the screen. However, he charged the absolute maximum that was permitted on the Apple App Store, $999. And he sold about 8 copies before Apple took the app down the next day. So Armin made about $5.5 grand after giving 2 refunds. My theory is that those unhappy customers were probably 2 kids who got a very bad beating that day. But funny enough, there's still plenty of I Am Rich clones out there in the wild, because Google and Microsoft don't seem to have a problem with people releasing these apps to their app stores. So you can buy your own on the Google Play Store, or even on the Microsoft Windows Store. Funny enough, the most expensive I Am Rich app on the Windows App Store is a real bargain at £8.50. We've got 3 goals in this tutorial. First, we want to get familiar with how Android Studio works. It's a complicated IDE with lots of buttons, so this is the perfect app for getting to grips with the program. Second, you're going to learn how to arrange user interface elements on screen and design a layout. And thirdly, you're going to get an introduction to XML and learn a little bit about how that works. Our version of the I Am Rich app is going to look a little bit like this. It's a quick and easy tutorial, and you're going to get your first app installed on your phone. You might not be able to show people that you're rich, but at least you can show them that you know how to design and create an app. So let's get started. You'll see Android Studio bring up this wizard. Now, if you're still on the splash screen, you can get to the exact same place by clicking here, Start a New Android Studio Project. Now, for this wizard, we're going to be supplying some pretty basic information, and then Android Studio is going to set up a project based on a template. So for the application name, we'll pick Minted. For the company domain name, you typically put in like the name of a website that you own. So, if you own adobe.com, this is what you'd have here. So if you own adobe.com, this is what you'd have here. And if you're a stationery company and you happen to own the website Pen Island, then this is what you'd put here. The thing that you'll notice is that the package name down here in gray changes as you're writing an application name or a company domain name. And the package name is basically the name that, when it comes to publishing the app, the Google Play Store uses to identify your app. What do I mean by identifying your app? Well, every app has a unique package name. And if you go to the Google Play Store, you'll see this package name in the URL in your browser. So if we check out Mr. Elementary Icons here, and you look at his package name, you can tell that they've copied this straight from a tutorial that they've seen online somewhere. And they're selling their app for 99p. Okay, so that's enough naming and shaming. So for the purposes of these tutorials, it doesn't really matter what you put as the company domain. You can put your first name, your last name. It doesn't really matter. Now let's move on to the project location. Now, if you remember from the Configuring Android Studio video, we set up a separate folder called Projects. In the Projects folder, we're going to save all our work. Now remember, if you're using Windows, you should have a Projects folder that you created on your local disk, on your local C drive. And your project location should be C/projects/minted. Just like this. So the full path, like the path. Click Next, and here you get to choose the form factor and the minimum SDK. So we're going to be making phone and tablet apps, so we'll have a checkbox in that first option right here. If you wanted the wizard to create a template for Android Wear or Android TV, you'd simply put a tick box here instead. Now, one thing that we're doing here in this case, of presented with a waterfall chart. What we're looking at here is actually really here. This means that 99% of Android phones will be able to run this I Am Rich app that we're creating here. Now, if we wanted to find out more, we can click on Help Me Choose and be presented with a waterfall chart. What we're looking at here is actually really, really interesting. So this is the breakdown of what Android version the phones out there at the moment are running, right? So we can see here that about 20% of phones, so the difference between 70 and 90, are still running Android KitKat. And only 1.5% of phones are running Android Nougat API level 25. The crazy thing is that Android Oreo isn't even on this chart yet, so there's very, very few phones that are new enough or updated enough to be running this version of Android. Now, you might actually ask, right, like, why does this matter? Why is this interesting? Well, so on the right-hand side here, we have a little pane. And in that pane, we can see what improvements have been made to Android with each version of the operating system. So if I click here on Jelly Bean, then I can see here that in Jelly Bean, they've got improved support for bidirectional text. And in the graphics department, we can see that support was added for OpenGL 3.0. And if I now select KitKat, I can see that the Android team has made a lot of effort to improve printing. So this is not only a nice little summary of what Android devices are running what versions of the operating system, but it's also like a nice little overview of what features were added in each version of Android. So you as a developer are making a choice. If you are making an app that needs to use one of the new features, then you cannot be supporting the very old Android devices, because that feature didn't exist yet. So for example, the 4K display mode was only introduced in Android Marshmallow, so you would set your minimum SDK as Android 23 if you were making an app that needed to use 4K display. Alright, so I hope that was an interesting little aside. I'm going to click OK and dismiss this window, and I'm going to choose API level 16 here because our app is going to be more of a work of art than needing to use the latest features. Also, API level 16 Jelly Bean was released in June 2012, so this means that any Android phone that was bought in the last couple of years should be able to run this app. So now I'm going to click Next, and here we get to choose a template for our app. So there's quite a few templates that are available, and we're going to go with empty activity. If you wanted to make a different kind of app, say a running app, you might choose Google Maps activity. If you wanted to make a tablet app, you might choose Master Detail Flow. And this choice basically determines how much template code is included in your starter project. So we only want a minimal amount of code included in our project from the beginning. So we're going to go with empty activity and click Next. We can give the activity a name. We're just going to leave it as main activity. And we can give our layout a name. But we're just going to leave the defaults with activity_main for our layout. We're also going to leave both of these checkboxes ticked. We want to tell the wizard to generate a layout file. And we also want our app to be backwards compatible. So we're going to leave a tick mark here with backwards compatibility. And now we're going to click Finish. Now what we'll see is a couple of windows of this thing called Gradle building our project. Gradle is the name of the build tool, and depending on the speed of your computer, this may be a slower process or a longer process. The important thing is that you can monitor the status of the build process down at the very, very bottom of Android Studio in the status bar. And as long as there's something going on here, as long as it says indexing or Gradle building, your project is still in the process of being on at the very, very bottom here with backwards compatible. But we're just going to leave it included in our project from the beginning. So we're going to go with, we can give the activity a name. We're just going to leave it as main activity. So now I'm going to click Next, and also going to, if you wanted to make activity a layout file, and we also want our app to be backwards compatible, so we're going to leave a tick mark here with backwards compatibility. And now we're going to click Finish. Now what we'll see is a couple of windows of this thing called Gradle building our project. Gradle is the name of the build tool, and depending on the speed of your computer, this may be a slower process or a longer process. The important thing is that you can monitor the status of the build process down at the very, very bottom of Android Studio in the status bar. And as long as there's something going on here, as long as it says indexing or Gradle building, your project is still in the process of being set up. So you have to wait. The next thing is that at the moment, there's all this red underline happening here in the code. And this is going to be the case as long as the build process has not finished. After the project has finished building, you should see a screen like this. You should see no errors, no red text, and that means that the project has been built successfully. So after our project has successfully been built, Android Studio will have dropped us off in the main activity.java file. However, to do the design, we have to navigate to a different file, namely the one where the layout is specified. And this is not the Java file, but the activity_main.xml file. You can find this file either by clicking on the tab up here, or alternatively, going to the project pane on the left-hand side and expanding the folders that you see there. So clicking on the down arrows, you can see that under app, we have a res or resource directory, and under res, we have another folder called layout. And when we expand the layout folder, there we have it, the activity_main.xml file. To open any of these files, all we have to do is double click on them, and then they show up on the right hand side. And then what you should see is a preview of a phone screen. This is the layout editor. In fact, there's two ways of looking at this file. There is the graphical way of looking at it, and this is in the so-called design view on the tab at the bottom. But there's also an option to look at the source code that's actually powering this layout. And we can see that by clicking on the tab next to design, which reads text. The source code for the layout file is written in XML, or Extensible Markup Language. So these are just two views of the same file, and you'll find yourself going back and forth between design and text quite frequently.
Now, one thing to keep in mind is that the Android Studio software updates over time. Unfortunately, this means that when you set up your new project from scratch using the Android Studio Setup Wizard, the template that you might get might be slightly different from what you see in the video.
To make sure that you and I are on exactly the same page and we have exactly the same layout in front of us, we're going to have to replace the XML code that was included in the template. So what you will see one file as a downloadable file listed under this lecture, XML starter code snippet.txt. If you click on this file, download it, and open it, what you will get is the XML starter code so that you can replace what's given to you in the template with what I'm using in the video. Once you open the file, it will look something like this. You can open this file in Notepad or in Atom or in whatever text editor you like using. The important thing is to just copy all the text in the file, go back to Android Studio, switch to the source code, select everything, and paste the copied code in here. What have we just done? Well, we have replaced the constraint layout, which was given to us by the template, with a relative layout. Now,
Alright, so first, grab and save it to your downloading. Extract the thing to Android Studio and add our app in the graphics that are folder pop up on your hard disk. From the extracted assets, add the diamond image to the drawable folder. And just like that, you've added your first graphic to your project. If you go back to Android Studio, you should see that in the project pane, the drawable folder should now contain the diamond image. Now let's return to customizing our layout. Within the activity main XML, scroll down in the palette until you see something called image view. An image view is like an empty picture frame in which we can hang our diamond image. Let's drag and drop an image view onto the center of our layout. When you let go of the mouse button, you should see a pop-up appear, asking you what image you'd like to display in the image view. Select the diamond image and click OK. And voila, you've just added an image view to the layout, and you've pointed that image view to a graphics file inside your drawable folder. You can also see this here under the image view properties. There's a property called src compat where you set the so-called source of the image view, and this is where you will see @drawable / diamond image. Alright, so let's customize our layout a little more. First thing we want to do is we want to change the background color to a nice blue. Now you want to be careful here, because you might be tempted to go over here and change the background. So let's find out what happens when we do that. We're going to click on the 3 dots. We're going to choose color, pick the primary blue, click OK, and take a look at our layout. It seems like our I am rich text has now disappeared, and it also seems that we have this ugly white border. And the reason is that we've set the background of the image view. The image view is taking up quite a big part of the screen, but there's still a margin left on the side. Also, we can see that in the component tree, the image view sits on top of the text view. Hence, when we change the background and make it blue, it retains the top and the text view. However, setting it's no longer visible. Image takes up properties, and we see the background behind a text size property that we set earlier. In this video, we're going to discuss what is XML and how does it work. In the late 1960s, early 1970s, a chap at IBM called Charles Goldfarb, who was trained as a lawyer, had the brilliant idea that it would be really useful to be able to put tags into documents to specify what the different parts of a document were. For example, if you had a top secret memo, you could mark who it was to, who it was from, and what the message is. At IBM, Charles and his team created something called GML, which stands for Generalized Markup Language, and came up with a notation for tags. In GML, tags used to look like this, but these days, we're more familiar with the pointy bracket notation that we see on the web. For example, you might be familiar with the P surrounded by the angle brackets that indicates a paragraph in HTML. Now, it turns out that once the word got out about Charles's idea of tagging, people found it to be incredibly useful for adding structure to documents. Because all of a sudden, you could tag things with what they are and what they mean. The memo earlier was quite simple, but tags in markup really found a home in large project documents in the government, law, and industry. Charles Goldfarb went on to create an international markup standard called SGML, Standard Generalized Markup Language, and wrote the Bible for document professionals. In fact, one of the earliest adopters of this tag set technology was the US Department of Defense. They used SGML to tag everything in their vast database with a suitable tag. That way they could make all their documents machine-readable, structured, and easily searchable. Remember, these were the days of punch cards. For example, one of the Department of Defense's big initiatives was called CALS, which established standards to exchange electronic data and technical documents. This was one of the largest early applications of SGML. But things really picked up in the early 1990s, when a certain Tim Berners-Lee decided that he was going to use SGML's pointy bracket notation and created a bunch of tags used to display something called a website. As you can guess, this was massively successful, and we all know that today as HTML. Of course, it comes as no surprise that in the early days of websites there